Hi guys, welcome to my channel. Right, today exercise we're going to take a look at automatic door. This automatic door. This logic is an automatic door logic. So this portion is the schematic for control circuit. Then here now is a schematic for power circuit. Now after this exercise, we're going to write a program and convert this sequence now to a ladder logic. We're going to convert this schematic to a ladder logic and download it to a PLC. Then PLC take over the operation of this, right? That is the next exercise. But now, let me just walk you through the operation sequence of this. Then later, okay, we have three exercises to perform. I'll walk you through the operation sequence of this. Then the next exercise, I will now teach you how to design this logic, right? How to design the logic and simulate it. Then the final exercise again is to convert this schematic to a ladder logic and now download it to a PLC and simulate it, right? And also carry out the wiring connection to PLC. So what we have here is automatic door and we have a manual operation of it. We have manual and automatic. So manual is for this session, then automatic is for this session. All right, before then, let me segment the narrative so that you understand this better. I will explain this portion. I will also explain this portion. Then I will explain this portion, right? Including this. So let's start with the power circuit. Now, power circuit, as you all know, that induction motor can be reversed. The operation of induction motor can be reversed. We can subject an induction motor to forward direction operation and the backward direction operation. Now, for the AC revision or method, I have a video I posted previously covering reversible motor starter for AC induction motor. Now, but the case of this particular logic, this one is DC motor. We want to design automatic door. We have two choices to make. One, either you are using DC motor or you're using AC motor. If you're using AC motor, the reversible type of function will take place in two methods. If you are using three phase, so you swap any of the two phases to get a revised function. If you are using single phase, you're going to interchange. There's a terminal called capacitor line and capacitor permanent and capacitor line, capacitor line, and capacitor permanent. These are three terminals that are single phase motor must be terminated to get it function. So you're going to interchange capacitor line and capacitor permanent, swap them at the outside the contactor, right? So when you are using DC, you're going to interchange positive negative to get the function of reversible, right? So but now we are using DC, so we are going to interchange this at the back of this contactor. So that is the function of this. Now come to this logic, this portion now. Let me introduce these two device. These two essential device that is the brain box behind the operation of the entire design. Now there's a relay here called on delay and off delay timer. This relay does two functions. This relay is on delay, is also off delay. When you energize this relay, it will put on the equipment, it will give you output. But how long will the output remains? It depends on the preset time. If you set it 5 seconds, when the 5 second elapse, it will shut down. Now, if you want to also use this relay for off delay timer, the shaded place here is off delay function. Then this other side with cross portion is the on delay function. So I use this particular relay to open the door and also close the door. So opening of the door is on delay function. Closing of the door is off delay function. So I use this relay to energize these two contactors. Now, for me to energize this contactor, how long will the function continues? It depends on this particular relay. This is on delay. So this on delay de-energizes the function of this on-off delay. I repeat again, for this contactor to close and open, the function, there is a device responsible for this function is this on and off delay. So what this one does is to send signal to this to open, also send signal to this to close. Now, how long will this sequence continue open, close, open, close? It now relies on this relay to cut it off. So once this relay on this one and off it, it will continue going off and on because that is the function. But this one will now cut it off. When this one open and this one closes, this one will shut down the operation because I don't need it again. So that is the function of these two, right? So on the manual operation of this particular design, I use this button. Button one is the particular button you press to get access, to gain access to the door, to the hall or to the house. Then when you are coming out to exit, you press this second one. So this particular one will be situated at the entrance. Then this other one will be situated at the exit side of the door, right? So any of them you press, this operation must take place, right? But if you press this one first, the door will open here. If you press this one first, door open this other side. That's the function of this. Then I also have another manual switch again. This particular switch will be incorporated with this device and enclosed inside a panel and they install at a suitable place within your installation time. Now, this one is the button you use during the troubleshooting or testing of the device. Subsequent time, this one take over. So this is the interface starting section, which you are going to mount close to the door. That is this particular one. Then this other one, we still need them. This one too. You have to enclose this particular one in an enclosure, in a panel, right? Okay, so this is the manual aspect of this particular design. Once I activate this, signal come to this contactor. This one will open. How long will this one remain? How long will this thing swing? It will swing, it will cut off immediately the door open and go 90, open fully. And what is going to shut it down is this limit switch. The same way this limit switch cut off this other closing operation. So that is for manual. Manual, you press here to do that. Then the automated system, automatic side of it belongs to this section. So this is a proximity sensor device. Proximity sensor switch I use. So when you come to the door and approaches the door within a little step away from the door, this switch should now sense your presence and send signal to this logic. And this logic will send signal to this contactor to open and close. So this one is sensor one, this one is sensor two. One of the sensor one will detect your presence when you are coming into the door. Then this one will detect your presence when you are going out from the door, right? Both of them energizes this particular logic and this schematic sends signal to this one. So let's see if we can simulate. I put this one on. Now I want this door to open. Let me gain access to the entrance. I click this particular switch, or let me use this. Now watch the arrow. This one opens. As you go out, it closes. It shut down. Now, if you want to come out, you press the second one. You now swing this other side and it shut down again. And the system shut down. That is the manual aspect of this design. Now, automated side of it, the automatic side of it belongs to this sensor. So once you approaches the door, this sensor senses your presence and sends signal to that same logic. Then the operation commences again. It shut down again. When you are coming out to exit the door, this one senses your presence as well and sends signal to this logic. And this one activates the door to swing. Right? So that is the function. Now, you can as well, let's do something. Let me increase this. Let me increase this to 6. If I increase this to 6, that is the time at which this particular device shut down this. So I also increase this to perhaps 6. Why do I increase this? What in a situation whereby this particular door is that type of a security door that bank uses. If you are using that type of